morning, everyone. I am Vizel Magsalay, and this is Tech TV. Today, the headlines is the most efficient algorithm, the merge sort algorithm. And we will be discussing the definition and answering some questions such as what is merge sorting algorithm? How the merge sorting algorithm differs from the other algorithm, and the time efficiency of merge sort algorithm.
Absolutely. Hi everyone, I am your Benladin Mohammadinin, your news anchor. Now Miss Gazelle, can you explain to us what is sorting algorithm?
A sorting algorithm is a technique for rearranging a large number of things into a given order, such as alphabetical, highest to lowest value, and shortest to longest distance. Sorting algorithms take input data in form of lists of items, conduct certain operations on those lists, and return ordered arrays as output. Since we specially said that today will be about merge sort algorithm, Mr. Benladin will introduce us the definition.
Thank you Miss Gazelle. So basically, it is one of the most efficient sorting algorithm that exists. It deploys the divide and conquer method, which we will explain more later on. In brief terms, merge sort constantly divides a list into many sublists, each with only one item, and then merges those sublists into a sorted list.
Yes, Ben, you are right. But to be clearer, we have prepared this short video that demonstrates a visual simulation of merge sorting algorithm in real-life events. Let's watch this.
Merge sorting algorithm. A senior student named Carlos is with his junior student schoolmates. He have a task to form a line according to the junior student's age, and it should be arranged from the youngest to the oldest. He first asked their names and ages, and each one answered. Anna is 9, Carol is 8, Ron is 11, May is 12, and Shane is 10. He first divides the group into two, then divide the first group into two again. Then he start in the first group and compare and rearrange their position according to their age. Then he goes to the next group and merge them, and compare and confirm their arrangement and order. Next he go to the other group because he is done with the first one. He compared the second group and their age and rearranged them according to the required order. Then he merged them all together and compare again and rearrange again and confirm the order, and he solved the problem. He solved the problem because he used the divide and conquer paradigm. To be specific, the merge sorting algorithm.
To add more information, we will be going to be also a live interview in the Western Mindanao State University. Let's see what new information we can get from an IT student. Let's see if they actually know about the merge and sorting algorithm.
Good afternoon everyone, I'm Fitzpatrick Humanagit from Tech TV, and as you can see, we are here today at the College of Computing Studies at Western Mindanao State University. And we are going to interview a couple of students to know their knowledge about the merge sorting algorithm. Let's go! As you can see, we are here inside of the College of Computing Studies, and what's left is to look for a student to interview. Good afternoon, sir. Can I interview, sir?
Yes, good afternoon. Yes,
What is your name?
I am Rafael Pizarro. I am Paolo Pangiban.
Great. What course?
I am taking Bachelor of Science in Information Technology. We are classmates.
Oh, that's nice. That's nice. So, sir, are you familiar with merge sorting algorithm?
Yes, we are. Yes.
So that's great because that's the main question for today. So here's the question. how do you differ merge sorting algorithm from any other algorithms out there?
The difference in merge sorting algorithm is that it uses a technique where it splits an array into half multiple times. The smaller parts are then sorted and compared until the final array has been created, which usually contains the sorted elements. The advantage of this algorithm is that it can work pretty well with larger data sets.
That's a great answer. It really shows that you're really knowledgeable. So, sir, my question about you, how do you know that merge sorting algorithm is time efficient?
As far as I know, merge sort algorithm is efficient because it has the time complexity of n log n for best, average, and worst case efficiency, which means that it's in the fourth fastest growth rate in terms of number of operation. That's all I know, and I don't know much of space complexity.
Okay, that's a great answer. And that's it, folks. That we already know that the students of Western Mindanao State University are really knowledgeable about programming. And I'm Fitzpatrick Imanagit from Tech TV. Back to you, Mr. Ben Laden.
Thank you, Fitzpatrick. Now let's see how an IT expert explained the merge sorting algorithm.
So, hi everyone, good day, and once again, it's Dion Cedric Marquez, your IP expert, and in this day, I will explain to you the general principle and how you will implement this in Python. Afterwards, I will show you an example on how you can implement this algorithm called merge sort. So first of all, merge sort is a divide and conquer algorithm. In general, this simply means that the problem is divided into multiple sub-problems, and then the sub-problems will also be divided into same algorithm to form more possible sub-problems, and this will go on until the sub-problems become more easy to solve. When we are at this point, the sub-problems are then combined to solve the original problem. This will probably make more sense when we get into the example of merge sort. Another point of merge sort is that it has O of n times log n running time, which is the optimal running time of comparison-based algorithms. So suppose we want to sort an array using merge sort. The general principle is to split the array in half. Afterwards, we call merge sort to those halves, and we do it recursively. And at the third step, we want to merge both halves into one sorted array, so here you can find this divide and conquer principle. Merge sort just divides the problem of sorting a whole array into sorting two arrays, a half of size, and this continues until we have just one array of size to sort, and this problem will be very easy because arrays of the size of 1 are always sorted. To explain this even further, I will show you an example that will clarify all the details of merge sort. So let us sort this example array of 7 numbers. First of all, we start with dividing the step of merge sort. Therefore, we will split this in half. We will look at the middle point. In this case, we have 7 numbers, so one side will be slightly bigger than the other. This will be no problem because we will just save the two arrays into 2 new arrays, and then this dividing will go on recursively. And we first look at the left part and divide it even further. Now we look at the right sub-array and divide this even further also. Dividing step will go on until sub-arrays have just one entry left. Because we have one entry left, the array is already sorted, and we can start combining. But now we need one more dividing step. So first 2 and 6, 5 and 1, 7 and 4, and the 3 will be left untouched. As of now, we sub areas and contain one element, so we can now start with the merging step, and now we're ready to merge these similar arrays into slightly bigger arrays that are already sorted. So therefore we start with 2 and 6. Now we see that 2 is less than 6, so we list down 2 and then 6. So these are at the next array. We see that 1, when we compare it to 5, 1 is lower, so 1, and then we list down 5 next, and next 7 and 4, so 4 is less than 7, so 4, and then now we list down 7. Then 3 will be left untouched because it is size 1 array. So next we will sort now, and we bring them together. 2, 6 and 1, 5. We see this, and we see that 1 is less than 2, so 1 will be first, and next will be 2. Wait, oh, there. Then we see that 6 and 5, and 5 is first and 6 will be next, of course. So next we compare 4, 7 and 3. So array will be listed as 3 at the first because it is less than 4. So next will be 4 because it is less than 7. Yeah. Of course, we bring down 7 because it's what's left. So now we merge this two slightly more bigger array. So the finishing step. So first we first put the 1, of course, and then we compare 2 and 3, and 2 will be first, so 5 and 3, then we put 3. 5 and 4 is lower than 5, so 4. Then 5 and 7, so 5 will be less than 7. 6 and 7, of course, 6 will be less than 7. This just leave us with 7, so it will be it will be completed as this. As you can see, the divide and conquer principle, we divided the array until we had every single problem of arrays that just set of the size of 1. And then we sorted this halves, and until we get this result. So next will be the sample code implementation in Python. So let's start with the sample code. I will write you a sample code for the merge sort to be more clarified when we implement this in Python. So let me first write a sample array that will give us something to test our implementation on. Now for the implementation, we define a function called merge sort in Python. So you define a function with the def keyword. Then writing the function name and writing the arguments in parentheses. In this case, we only have one argument and in an array. Don't forget to end this line with a colon. Now we are starting to define a function. First of all, a function is only does something if the length of the array where choose sort is greater than 1. If the array is not greater than 1, the array is already sorted. We have nothing to do. So, start by defining the recursion part of this algorithm. Therefore, we need to define two sub-arrays. One that goes from the beginning of the original array to the middle point, and one, I call it right array, that goes from the middle to the end of the array. In Python, you have this special notation to get slices of arrays. So this notation just returns slices of the original array, beginning at index 0 and ending at the index length of array divided by 2. The right array, on the other hand, starts at length of array divided by 2, so in the middle, and goes on to the end. If you leave a blank left of this colon, this has the same meaning as if you would insert a 0. And if you leave a blank after the colon, this has the same meaning as if you would insert a length of array and the double slash. Does mean that you want to do integer division. So normally you would get a decimal out of this computation. But you just round this decimal off the next integer. Now we are ready to call merge sort recursively on both of these arrays like this. This just says that we want to do a whole merge sort algorithm on the left array, and we want to do a whole merge sort algorithm on the right array. And after these two lines, both left and the right array are in sorted order. When you remember the example, after two arrays are sorted in sorted order, we want to merge them and make a bigger array than them is sorted. So now we are ready to implement the merge step. And in the merge step, we remember that we want to compare the leftmost element of one array to the leftmost element of the other array. I will use this index I to keep track of the leftmost element in the left array, and index j to keep track of the leftmost element in the right array. And now I will use of while loop. Inside this while loop, I will do the comparison. The comparison just compares the left array and at index I with the right array at index j. And actually, let's use a third variable that keeps track of the index in the merged array. So let me comment this merge array index. Merge array index, left array index, and right array index. And now when we see that the left array is smaller than the right array, at our current indexes, we can save the value of our left array inside our merged array. Then we just have to increase I and we have to increase k. In the other case, the right array is smaller than the left array at the current indexes, or they are equal. So in this case, we just have to do the same thing, but we save the right array index j in the merged array in the next game. And in this case, we have to increment j and k. So just to make this a bit shorter, because of both cases, we have to increment k and I. Just delete this row and pull this row in front, so we increase k in every while loop. But now imagine that we already looked at every element in the right array and we transferred every element from the right array to the merged array. There's nothing to compare left to the leftover elements of the left array with, and now we just have to consider the case that we want to transfer every element from the array, from the left array to the merged array without considering the right array. And in this case, I is still smaller than the length of left array because there's the elements missing from the left array to transfer to the merged array, and now we just want to transfer them by assigning the left array at index I to the merged array at index k. Afterwards, we need to increase both indexes, and analogically we need to implement the case that every element from the left array is already sorted. But there are some missing elements of the right array, so we just do a very similar while loop but in this case we check if we are not at the end of the right array, and we just assign every element of the right array at our merged array. So these are all cases that we need to consider to implement the merge sort. And so we implement the recursion, and the merge step we basically finish. We're basically finished, and now we can go down to our test array and call our merge sort function on this array. So just by typing merge sort and array test in parentheses, and afterwards we can call the print function our array test on our array test to see if we were successful with our implementation. So let me just run this code, and actually this is the result. You can see on my console, and this is what it looks like. It looks like a perfectly ordered array. So this is everything we wanted, and we were successful. So I hope you guys learned something.
Yes, thank you, dear Marquez. And that's all about merge sorting algorithm. Good day, everyone. I am Melody Mohammedini, your news anchor.
And I am Lizelle Magsalay, your news anchor. And this is
Tech TV.